This is section 6.6. We are going to be working with quadratic equations. Remember, with quadratic equations, you're going to have some sort of x squared term. That's what is the definition of quadratic, when you have an x squared term. A binomial is an algebraic expression containing two terms in which each exponent that appears on the variable is a whole number. This would be an example of a binomial. Notice you have this term x and this term, which is positive 3. Other examples of binomials, you have 5x and a negative 3 has two terms. Remember, binomial has two terms. When you multiply two binomials together, I'm going to have you forget about the FOIL method. If you prefer to multiply with the FOIL method, I don't care, as long as you get the right answer. Just multiply them, okay? But remember, you don't just multiply the x with the x and the 3 with the 4. That's not how it works. When I teach my students about multiplying binomials, I usually use what I call the box method because, you know, boxes. So this is x plus 3, so I have an x and I have a positive 3. And this is x plus 4, so I have an x and a positive 4. Now when I multiply using the box method, I have to multiply the x times the x. X times x is x squared. I've got to multiply the x times the 3, and x times 3 is 3x. Now the bottom row, I now have 4 times x, and 4 times 3 is 12. And to write my answer, I'm going to combine like terms. You notice my like terms happen to be on the diagonal. That will happen almost every time. So I've got x squared. That's not like anything else. I have a 3x and a 4x. When I add those together, I have 7 x's and a positive 12. Now this has three terms. We call it trinomial. So the answer, x squared plus 7x plus 12. A trinomial, a simplified algebraic expression that contains three terms. If we multiply two binomials, we usually get a trinomial, but not always. Factoring an algebraic expression containing a sum or difference of terms means finding an equivalent expression that is a product. Yeah, and if you can make sense of that. So let's actually work on factoring. We have a quote-unquote strategy for factoring. This is from the book. It's kind of old-fashioned. They tend not to do much of this anymore. I'm actually going to show you my method for factoring, and there's actually many methods for factoring. I'm going to show you maybe one or two methods for factoring. So since I showed you the box method for multiplying, I'm going to show you the box method for factoring. Okay. Now if you recall from the last example, we had an x squared in the upper left-hand corner, and the bottom right-hand corner we had the constant, which in the last example was 12, but for us it is 8. And we're going to worry about the 6x in a minute. Okay, so we'll just hold off on that 6x. Now our answer when we're factoring is going to come with the stuff that's outside of the box, not inside the box. So what we have right here is an x squared, and what we're looking for is two things that will multiply to get x squared. Well, the only way to get x squared is to multiply x times x. We also need to figure out what we're going to multiply to get 8. Now there we actually have different options. We can multiply 1 times 8. We could multiply 2 times 4. And those are our only options for multiplying to get 8. So we have to actually check to see which one is the correct one. So let's fill in the box. If this were 1 and x, this would be 1x. x times 8 would give me 8x. And if I were to add these together, now that it's all messed there, this one would be x squared plus 1x plus 8x is 9x plus 8. Well, if you look at the original problem, it was x squared plus 6x plus 8, which is not x squared plus 9x plus 8. So it cannot be this box on the left. So let's check our answer for the box on the right. If we take 2 and multiply it times x, we get 2x. 4 times x will give me 4x. And if I add, I have x squared plus 6x plus 8, which is the original problem. So that tells me the box on the right is the correct answer. Now we just have to figure out how to write the answer. So remember, this is positive 4 and this is a positive 2. So my answer is x positive 4, x positive 2. X plus 4 times x plus 2 is the answer. All right, for this example, I'm going to show you a different method. You can use the box method. It's your choice. I don't care. But probably an easier way when you have a coefficient here, right here, is to use what I call the AC method. Okay, so I'm going to show you the AC method. So the AC method, you need to know that standard form for a quadratic is ax squared plus bx plus c, where the coefficient for the x squared term is your a. So in my example, a is equal to 3. The coefficient for the x term is your b. So in our example, b is equal to negative 20. And the c is the constant, or 28. Now the AC method literally means AC, or A times C, which in our example, A is 3, C is 28. So 3 times 28 is 84. So what you're going to do is you're going to make a T-chart with 84 at the top. And you're going to list all of the pairs of factors for 84. What times what will give you 84? Keeping in mind that we can multiply a negative times a negative and get a positive 84. So I know that 1 times 84 is 84. I know that negative 1 times negative 84 is also 84. 2 times 42, negative 2, negative 42. 3 times what? 28, I believe. Yes, 3 times 28. Negative 3, negative 28. It's going to be a long chart here. Keep on going. Got some more. 84. Does 4 go in? Yes, it does. How many times? 4 times 21. Negative 4, negative 21. Does 5 go in? No. 6. It looks like 6 goes in because 2 and 3 go in, so 6 must go in. 6 goes in there 14 times. 7. 7, yep, 7 goes in 12 times. Negative 7, negative 12. Does 8 go in? No. How about 9? No. 10, 11, and 12. We know 12 goes in, but we already got that in our table. So our table is done. Make sure you do every single possibility. From here, what we're going to do is we're going to add those pairs together. In other words, we're going to add the 1 and the 84. What's 1 plus 84? Well, it's 85. My goal is to find negative 20. Well, 85 is not negative 20. Negative 1 plus a negative 84 is not negative 20. 2 and 42, 3 and 28, 4 and 21. Let's look at 6 and 14. If I add 6 and 14, I get a positive 20, which is at least headed in the right direction, but it is not negative 20. How about negative 6 and negative 14? If I add those together, I get, indeed, negative 20. So I'm going to circle that pair, negative 6 and negative 14, and go back to the original problem. So my original problem was 3x squared minus 20x plus 28. Now, normally when you work with this kind of thing, you do what we call combine like terms, and you take your two x terms and you add them together and you get this middle x term. Well, what we want to do actually is to break up this middle term using negative 6x and negative 14x. So I still have my 3x squared, but instead of negative 20x, I'm going to write that as negative 6x minus 14x, and I still have my plus 28. Now, if I were to add these together, I should get my negative 20. Now, I don't want to add them together because I just got done unadding them together. But if I were to add them together, I should get the negative 20. So from here, I have four terms. I'm going to underline the first two terms. And a separate underline, I'm going to underline the last two terms. Now, just looking at the first two terms, only the first two terms, I'm going to look to see what they have in common. Okay, what do they both have? They both have x's and they both have 3's. Or I can divide 3 into both of them. Okay, so what I'm going to do, I'm going to put a 3x, because they both have 3's, they both have x's. I'm going to put a set of parentheses. So I need to divide out 3x from both of these terms. Okay, so I'm dividing 3x out of 3x squared. I'm dividing 3x out of 3x squared. Well, I'm dividing the 3's out. If I divide out the x, I'm left with x. And if I divide out, so I have negative 6x divide out a positive 3x, I'm left with a negative 2. I'm going to do the exact same thing with the second or the last set of numbers. What do they have in common? What do they both have? They do not both have x's, but they do both have 14's. And since this is a negative 14x, I'm going to put a negative 14. If that had been a positive 14x, I would have put a positive 14. Yes, you do have to put the plus. And I'm going to divide out negative 14. Be very careful. You divide out a negative 14. And if I take negative 14x, divide out negative 14, I'm left with x. If I take 28, divide out a negative 14, it's negative 14 I'm dividing out, I get a negative 2. At this point, I have an x minus 2, so I'm going to write x minus 2. And in my second set of parentheses, I'm going to do 3x negative 14. And you're like, how is this faster? Well, trust me, you could guess and check your way into infinity and still not get the correct answer. So even though this is a lot of work, it is still going to usually be faster, unless you happen to be a good guesser, than the box method for factoring if you have a coefficient of 3 or 4 or 5 or 6. If that coefficient is anything other than 1, you're going to want to use the AC method. So the answer, x minus 2, 3x minus 14. All right. A quadratic equation is quadratic. We have an x squared. But an equation now, we have it equal to something. We have it equal to 0. Zero product principle. Well, that's going to kind of seem like a, well, yeah. If I multiply two numbers together and they equal 0, that must mean that either one of the numbers is 0 or the other number is 0. So say, for example, I tell you that I have 2 times some number, I don't know what it is, equals 0. The only way to multiply 2 times something and get 0 is if this number right here is 0. That's exactly what I just said here. If I multiply two numbers together and it equals 0, then one of the numbers must be 0. All right. I am going to split this into two parts, so I'm going to stop the first part here,